Now it's time to move into some geometry topics. So we're going to talk about distance, midpoint, and Pythagorean theorem. Okay, so distance and midpoint, we have a formula. Actually, all three of them, we have a formula. So for our distance formula, it is the square root, so one big radical, of x2 minus x1 squared plus y2 minus y1 squared. All right, and then the x2 and y2 and x1 and y1 come from the points that we're given. Right, so if I give you a 2 and a 3 and 5, 7, we just use our 2 points, just like we did with our slope formula a while ago. Okay, so midpoint has a different formula, and our midpoint is just that, it's a point. Okay, so our midpoint's going to be one big ordered pair. Okay, and it's a fraction. We're finding the middle of our point. So we're actually finding like the average of our x's and the average of our y's. So I'm going to take x plus x and divide by 2, and y plus y and divide by 2. Now, I could say x1, x2, right, and then y1, y2, but when we add, order doesn't matter. So what matters is that I take my x's and add them together and divide by 2. Then take my y's and add them together and divide by 2. All right, so in subtraction with our distance formula, order matters. When it comes to our addition in the midpoint formula, order does not matter. Okay, and then we got Pythagorean theorem. Let me scooch up. So the Pythagorean theorem is actually like a sentence, right? It says, if a triangle is a right triangle. So I have to know that it's a right triangle, and the problem will either tell you straight out that it's a right triangle, or it'll give you a triangle, and it'll label that box in there. So the box means the right angle, it's 90 degrees. So if a triangle is a right triangle, then we can say that a squared plus b squared equals c squared. Right? And then A, B, and C are the sides of your triangle. C in particular is the longest side, and that's what we call the hypotenuse. Hypotenuse. All right, so C has to be the longest side. That's the only part that matters when it comes to plugging in A, B, and C. Right? We also have what we call Pythagorean triples, which if you recognize these now or when you're doing a problem, you might not have to do the whole Pythagorean theorem, because once you recognize a triple, you can just fill in the rest. So our common triples, we've got, let's see, get where my paper doesn't move. We've got 3, 4, 5. All right, 5, 12, 13. 7, 24, 25. And 8, 15, 17. So these are just common triples. It's not all the triples that are out there, but these are common ones, and they're Pythagorean triples because they are numbers that work nicely in the Pythagorean theorem, right? And what I mean by that is that 3 squared plus 4 squared does indeed equal 5 squared. Right? So it's some that just, they plug in and you see them often, right? So if you recognize that you have sides 3 and 4, then you know automatically that your hypotenuse can be 5 just by knowing your triples, right? Or it might not be 3, 4, 5, but it might be 6, 8, 10. If I take these 3 times 2, those are ratios of these sides. So it could be 6, 8, 10, 30, 40, 50, any ratio as long as it comes down to 3, 4, 5, right? Those are triples. All right, now, also, the distance formula is kind of ugly to memorize, so you could use the Pythagorean theorem instead of the distance formula. The distance formula actually comes from the Pythagorean theorem. So let me scooch back down here. So if I have my theorem here, right, this is saying that if I have a segment, we'll draw a segment here, okay, if I were to take that segment, instead of finding the distance using the ordered pairs, I'm going to draw a triangle, and I'm going to draw a right triangle, just like we did with our slope. Okay, I'm going to turn that into a triangle. This distance going up, let me switch back here. Okay, this distance going up here, right, is if I took my top y minus the bottom y, right? So let's see, we'll call this x1, x2, oh no, y1, oops, x2, y2. Okay, so this distance here is if I take my top y, so y2, and I subtract the bottom y. I'm taking this top piece minus the bottom of that segment. So that's y2 minus y1. This bottom piece is the same thing if I do my x's. So I take that top x minus the bottom x. Okay, well, if I kind of move ahead and instead of calling this, y2 minus y1, if I call this side A, and then I call this side B, and A is y2 minus y1, and B is x2 minus x1, well, now I can do the Pythagorean theorem, and we can say this side over here, we would get a squared plus b squared equals c squared. Okay, that in turn, because A is y2 minus y1, I can say that that's a squared, and then my b squared is x2 minus x1. That has to equal c squared, right? Well, to get c by itself, we square root both sides, and voila, there's my distance formula. Okay, so instead of actually plugging all of that in, I can just draw this triangle, and I can count. I can count how tall this is, I can count how wide this is, and then plug that into the Pythagorean theorem. So we'll practice that in just a second. Okay, let me get my examples brought up here. All right, so I want to find the exact distance and midpoint for these 3 points. Okay, so I'm going to start with midpoint just because that's quicker, a little bit easier, right? So I'm just going to plug into my midpoint formula. All right, so we've got m equals, okay, add my x's, so we'll say 6 plus 3 divided by 2. Oh, sorry, it's blurry. Okay, and then I'm going to add my y's. So I have -3 plus 1 divided by 2. All right, let me see if I can make that clear by zooming in some. See if that helps. Sign is kind of blurry. I don't know what's going on. All right, so 6 plus 3 is 9. 9 is not divisible by 2, so I'm going to leave that as 9/2. All right, and then -3 plus 1 is -2, and -2 divided by 2 is -1. So my midpoint is at 9/2, -1. Okay, I'm going to do that again over here for number 2, and just do our midpoints all the way across. So I have -5 plus 5 over 2, -7 plus -2 over 2. Okay, -5 plus 5 is 0, and then 0 divided by anything is 0. Okay, -7 plus -2, that's -7 minus 2, so that's -9 over 2. And again, I can't simplify that, so I'm just going to leave it. If you wanted to, you could put that as 4.5. All right, and then for the third one, we got 4 plus -2 over 2. And then I got -1 plus -1 over 2. So 4 plus -2 is 4 minus 2, and that's 2. And then 2 divided by 2 is 1. -1 plus -1 is -2, and -2 divided by 2 is -1. So there's midpoints across the board. You add the x's divided by 2, add the y's divided by 2. Distance, all right, the first two I'm going to do using my formula. Okay, so just to remind us, come back up here. All right, there's my distance formula. Now, what matters here is, one, that we're doing subtraction, but with subtraction, order does matter. So whatever point I start with the x, that's got to be the y, right? This x and this y have to go together. Then my second x and the second y have to go together. It doesn't really matter which one you start with, as long as you line them up as you go through the problem. All right, so over here, let me get my big square root going. All right, so I'm going to start with my x2 minus x1. So x2 would be 3 minus x1, 6 squared. All right, y2, 1 minus y1, -3 squared. 3 minus 6 is -3. 1 minus negative, so negative, negative becomes a positive. So 1 plus 3 becomes 4. And then don't forget to square them. Common mistake is you forget the square. So -3 squared is +9. And 4 squared is 16. When you square something, no matter what, it's going to be a positive number. Okay, 9 plus 16 is 25. And the square root of 25 is 5. So the distance between those points is 5. All right, we're going to do it again for the second one. We're going to do the distance formula. So we got distance equals our square root. Okay, starting with my x's, I have 5 minus -5 squared. And then my y's, -2 minus -7 squared. Okay, 5 minus -5 becomes 5 plus 5, and that's 10 squared, plus -2, again, minus a negative becomes plus, so -2 plus 7 is a 5. 10 squared is 100, and 5 squared is 25, so that leaves us with the square root of 125. Now, here's where that exact distance comes in. Exact means I'm not rounding at all. So when I plugged in over here, and I got square root of 25 was 5, okay? And again, I know we talked about when we take the square root of a number, we consider the positive and the negative number, but in terms of distance and length, we don't have a negative distance or a negative length, so we only worry about the positives here. Okay, but 25 was a perfect square, so the square root of 25 is 5, and that's my answer. I'm not rounding, that's exact. 125 is not a perfect square. So if I type that in the calculator, I'm going to get a decimal. I'm going to get, let's see, 11 something, 11 point something. Okay, but that's an irrational number. It doesn't end. I would be rounding if I stopped it at a certain number of decimal places. So to leave it exact, leave it just like this, square root of 125. And we're not worrying about breaking it down. So when it says to leave it exact, you leave it under the square root if you cannot take the square root of it. If you can, go ahead and take the square root and get that number. If it just wants you to round to the nearest tenth, go ahead and type it in the calculator and get your decimal, right? But if it wants it exact, leave it under the square root if it's not a perfect square. All right, the last one I'm going to do using the Pythagorean theorem. So I'm going to come back to that after we practice the Pythagorean theorem, okay? So the missing sides down here, I've got 3 right triangles, right? So I want to find my missing side using the Pythagorean theorem. Remember, the hypotenuse, the longest side, has to be your C. Okay, so when you're looking at your triangles here, the side that's across from your right angle, that's your hypotenuse. So in this case, I'm looking for C. I'm just going to plug in my formula. It does not matter what A and B are. You can pick either one to be whatever. The only one that matters is that C is your hypotenuse. So when I start plugging in, I'm going to say 24 squared plus 10 squared equals C squared. All right, then I'm going to simplify. 24 squared is, let's see, 476. All right, and then 10 squared is 100. 476 plus 100 is 576. And then I got a square root to get C by itself. So then C ends up being 26. So that's my missing side. All right, for number 2, 16 has to be my C. So I'm given C this time. So I'm going to call this other side A. It could be A or B. Doesn't matter. And then I'm just going to write in my equation. So I don't know what A is, so I'm going to leave that as A squared. B has to be the other, what we call the leg of my triangle. So A squared plus 9 squared has to equal C squared. So 16 squared. Then we simplify. So A squared, 9 squared is 81. And then 16 squared is 256. All right, got to do some mental math over here. Let's see, we got to do 256 minus 81. So that's going to be 75. Double check. 175. Let's see, I think. Might be thinking too hard about it. 256 minus 81. Got 5, and then 25 minus 8 is 17. Okay. All right, so we got 175 square root. All right, 175 is not a perfect square, right? So if it wants a decimal, type it in and get your decimal. If it wants exact, you leave it as the square root of 175. You just got to wait and see what the question's asking. There's some of both in your assignment. All right, and the last one. All right, I got 5 and 11. The 11's across from the right angle, so that one's got to be my C. And just because we used A last time, I'm going to call that leg B. Does not matter if it's A or B. I'm going to write my equation, so we can say 5 squared plus B squared equals 11 squared. 5 squared is 25. All right, 11 squared is 121. Subtract the 25 over. All right, 121 minus 25 would be 96. Square root, and again, if it asks you for, oh, sorry guys. If it asks you for a decimal, you can go ahead and type that into the calculator. If it doesn't, if it wants exact, you can leave it as a square root of 96 because exact means we're not rounding. Okay? All right, now for the next one. Whoops. Actually, we should have just done this one. This one's a weird looking one. We'll do this both ways. Well, I'll show you the graph of it in a second. So I'm going to plug it into my distance formula. Forgot what examples I chose here. So I'm going to choose my second x, so -2 minus 4 squared plus, we got -1 minus -1 squared. All right. -2 minus 4 is -6. -1 minus negative becomes +1. That's 0. All right, -6 squared is 36. 0 squared is 0. So that just ends up being the square root of 36, which is 6. All right, so I'm going to kind of look at 2 examples here. We don't have to do the whole thing because you should be able to see the pattern. All right, if I were to need a better sheet of paper, we'll use this side over here. Okay, I'm going to graph these 2 points at -5, -7, and 5, -2. Maybe. Come down here, way down here. All right, so I've got -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So there's a point, and then 5, -2. So 1, 2, 3, 4, 5, -2. All right, so here's the segment I'm trying to find the distance of. Instead of using the distance formula, I could just use my Pythagorean theorem. And all I have to do is draw a triangle. Doesn't matter, I can draw a triangle down here, or I could draw a triangle up here. Doesn't matter. All that matters is that I draw a triangle, and it ends up being a right triangle because I have a vertical and a horizontal line. So they're going to form a right angle there. They're perpendicular. Okay, and then what I'm looking for is this distance here, C. Right? Well, I can count. I can say that this is 1, 2, 3, 4, 5. That length right there is 5 units. I can count up and down, left and right all day long. Just can't count diagonal. Right? So if I count this way, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I were to do Pythagorean theorem, this would be 10 squared plus 5 squared equals C squared. Okay, well, if you come down here to what we already did, I have 10 squared plus 5 squared, and the square root of it, which is what I'll do when I get C by itself. Oops. So it works the exact same way. All right, so I could go ahead and solve. So we would say 100 plus 25 equals C squared. So 125 equals C squared. Square root it, and the distance of my line is the square root of 125. All right, now the second one, or the third one that we did up here, see, we got 4, negative 1. 1, 2, 3, 4, negative 1, and negative 2, negative 1. Okay, this one is a horizontal line. I can count left, right, up, down all day long. So this one, had I graphed it, I wouldn't have even had to do all that algebra in there. I can just count and see that this distance here is 6. All right, the way that you know if it's a vertical or a horizontal line, that all you have to do is count, is if your points have something in common. So here they both have a negative 1 for the y value. So if they have the same y value, that means that it's going to be a horizontal line. If they have the same x value, that means it's going to be a vertical line. So you can save yourself a little time. Not that it's that bad plugging into the distance formula, but you can save yourself some time if you recognize it and then just sketch a little graph and see how far apart they are.